Hello everyone. In this video, we're going to solve this electromagnetism problem, which is related to electromagnetic radiation. So let me state what's in the question. So we have the governing equation nabla square 1 by c squared del t square acting on psi rt gives us this 4 pi f rt. Now psi can be two things. This is basically the potential. One is vector potential, another is the scalar potential, and the corresponding f is 1 by c j and rho. So this j is the current density, this rho is the charge density. Now the solution for this equation, the solution for psi, is straightforward. Considering the retarded time, we can write down psi to be, if we want to relate psi with f, then this is the equation. R prime, t prime is the retarded time given by this expression. R is the difference between r and r prime. Right? So r prime belongs to the source, and r is the observation point. Okay, and it's this equation is given in the question here. We just want to use it, and trust me, we're going to use it heavily. So with that in mind, also we have taken the Lorentz gauge, hence the potentials are governed by this equation. So with that in mind, let's move to the first question. Question A, which tells us to take the Fourier composition of the potentials and the corresponding densities. We have to take Fourier compositions of these four things, and we know that a and j are related using this equation. So what we have to do, we have to relate the Fourier counterpart of a denoted by this to the Fourier counterpart of j denoted by this. We have to relate these two things. And similarly for phi and rho. So it's also given that A tilde is given by, is the definition actually of A tilde, coefficient, the Fourier expansion of ART. Hence, you can write ART as d omega e to the power minus I omega t tilde r omega, right? And the same thing holds for j by definition, dt to the power I omega t r t. And so you can write, my bad, RT as I omega t j tilde r omega. Right. Now we're going to use this thing, right? So let me write it down again, or I could just yeah, could just use this. So what we're gonna do is we're gonna compose this thing. Use this definition. Omega minus omega t. This is related to this. Here. Prime t prime, which is t minus c divided by r. Now decompose this thing. This is t prime, obviously. So this t prime is divided into two parts. One is t and another is minus r by c. And so we're going to do one thing, that is we're going to take the t part outside. So omega t. So inside we'll have plus, have plus I omega r by c along with j tilde. Right. Now take this thing to the left and collect the terms. We have this integral, this volume integral, and this thing turns out to be 0. Right. Now this is a function of, let's see, r omega, and is this a function of r prime? No, it's not, because this r prime is being integrated over. So yeah, it's a function of r and omega, and we have this integral here, omega integral here. Now what I claim now is this, if this is 0 for all t, then this f of r omega, this thing has to be 0. I mean, there are multiple ways to see how this comes about. First, notice you can think of this integral as a sum over different bases, different elements of a basis, and those elements being there's this thing omega 1 t, another basis element is this, and it goes on, right? So and these elements are linearly independent. So we know from the definition of linear independence that if they are added to 0, then their coefficients must be 0 individually. So that sort of justifies this equation. Also, we can approach this a bit more mathematically, but it's the restatement of the fact that I've just stated. Let's do that to be like really airtight. So so we have this, right? So now what we can do is we can introduce a factor. Sorry, introduce a factor e to the I omega naught t, and multiply both sides with that. So have and we can do dt integration. And this thing, rearrange it. This thing is nothing but the delta function, delta omega naught minus omega, and the rest remains the same. So what we have is we have f r omega naught minus z. So this thing is justified, and we have as a fact this whole thing to be 0. Let me see if we just use this side. We have this thing is prime I r c tilde r prime omega by r. Yeah. So we have managed to show a tilde as a function of j tilde, right?